Okay, you are getting ready for the chemical equations quiz. What do you need to know? Well, the highlights are this. You've got reactants and products, and you've got a written equation with a couple of symbols. You've got coefficients and subscripts, and you've got extra stuff that we'll cover as we go. So let's go and look at the highlights. So this is a chemical equation. And I think I want to start with the big stuff. So everything on the left side of the arrow is called a reactant. So this chemical reaction, or this equation, has two reactants. And then, when the reaction happens, you get something. You get products. So products are what you make, and they are on the right side. So the reactants yield the products. And if you don't want to say yield, you could say produces. Or maybe you could say makes. Or maybe you could say becomes. Those are all good. And the arrow here in the middle, the arrow shows you the direction of the reaction. But it doesn't always have to be left to right. Sometimes you can have a chemical reaction be reversible, and you might see an arrow that points back. So you might see this double arrow thing. All right, so let's move on. Let's look at this 6CO2 thing here. 6 CO2s. Well, the 6 tells us how many CO2s we have. But what about this little 2? This little 2 tells us how many atoms we have of the O. So just to get a little more in depth, this is what carbon dioxide, that's what it is, that's what it looks like, is this. You got a carbon atom, and you've got an oxygen atom here, and you've got an oxygen atom here. That's carbon dioxide. So you see that there's one carbon atom and two oxygen atoms. That's why the formula is CO2. But what this is saying, this 6, this is called a coefficient. Just like in math class, it's like a big number in front of x, like 2x or 2xy. It's saying you've got 2 x's and 2 y's. This coefficient says you've got 6 CO2s. So let me come back in a second, and I'm going to draw a few more of these ugly drawings. Okay, I warned you it was going to be ugly. So, yes, 6 CO2s. So here's 1, 2, 3, 4, 5, 6. So if we were to count this up, looking at the coefficient of 6 here, how many C's do we have? Well, 1, 2, 3, 4, 5, 6. So 6 times 1. Remember, we don't write the 1's in the chemical equations. We just assume they're there, or they're implied. And then how many oxygen atoms do we have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's because 6 times 2. We've got 12 oxygen atoms in 6 CO2s. And I didn't mention officially, this little 2 down here is called a subscript. Now look at that horrible writing. I'll just sneak over here and draw an arrow at this little 2. That's called a subscript. And that tells us how many atoms there are in that particle. So there's 2 oxygen atoms per particle of oxygen. Okay, what else can we show in a chemical equation? Well, we can tell you what state of matter we're talking about. So right here, this CO2 is in gaseous form. This water is liquid. This C6H12O6, this sugar, this is a solid, and oxygen here is a gas. So you can tell the state of matter from a chemical equation. So what do we have next here? Extra stuff. Sometimes you can get crazy looking equations. This looks like it's really complex, but let me just show you what's here. Here we've got our equation, or I'm sorry, our formula, and here we've got our state of matter, and this is just the common name for it. So these equations, like NO, you guys would call it nitrogen monoxide because you've already passed the covalent naming quiz, but the common name for it is nitric oxide. So you can put the words down of the equation, of the formulas. Let's see here. Oh, nickel. This is telling us that this reaction happens when nickel is involved. Nickel helps these guys get together to make this guy. This is called a catalyst. And we put it on the arrow because it doesn't change in the reaction. It stays the same. What else can we see here? We've got temperatures. So we can write the temperature that this reaction happens. Or right here, this reaction happens with chlorophyll as our catalyst, and it happens in the presence of sunlight. So we can add all sorts of little extra things to chemical equations. I'm at 5 minutes. Let me just zoom through this last little bit here. This equation shows gaseous water, so that's the water vapor in the air that we're breathing right now. And if we take that gaseous water and we condense it into a liquid, it gives off heat. So that means we can also put energy into a chemical equation. And with this top one, the energy is on the right side, so energy is a product. If you were nearby and this were happening, this would actually feel warm because it gave off this heat energy. And then this one down here, the energy is on the left side. So if you want to take solid water and melt it into a liquid, you have to put energy in. So if you were in the neighborhood where this was happening, it would feel cool or cold. So energy can be part of a chemical equation. And now I'm at 6 minutes. Last thing I have here. Instead of writing it, instead of writing it as words or even just formulas, this is structural. And why would somebody do this? Somebody would do this because they want you to be aware that, okay, you've got one carbon atom bonded to 4 different hydrogen atoms, and this is methane. And this one right here, you can see that the bonds that go between carbon and oxygen, there's 2 dashes here. That's 2 pairs of electrons being shared. So you can show a lot more stuff than just, O2 plus H2 makes H2O. And that is my video on chemical equations.